Hey there, this is Josh, and today we're going to be simplifying exponents. And so I'm going to take you through the basics of it and then work through a handful of problems over here. This is another situation where I think it's good to have a handful of these up, so that way if you feel like you're getting it, then go back, watch the video, check your work and stuff like that. So that way, pause the video if you feel like you're confident on this stuff, try a couple of them, see if you're making mistakes or if you're getting it right, and then keep on trucking. All right, let's write this thing out. Before we do that, let's just talk about exponents for a second. Okay, if we have 2 to the third, really what we're saying is we have a number, okay? And this guy down here is called the base unit, okay? And then this guy up here is the exponent. All right, and really what we're doing here is we have a certain value, and then we're being told how many of them we have to multiply together. And so we could look at 2 to the third as 2 times 2 times 2, right? Because the base unit is 2. How many of them are there? Oh, well, they're telling me that there's 3, okay? And to kind of tie this together, when it comes to reducing fractions, if we have a 4 over an 8, we know we can reduce that down to, well, we can take them both, divide them both by 4 and end up with 1/2, okay? But we could also do other stuff. We could make that into a 2 times 2 on the top, which is 4, over 2 times 2 times 2, which is 8, and we can reduce. We have numbers on the top and the bottom of a fraction, and they're being multiplied together. The thing that's going to allow you to cancel them is the fact that they're getting multiplied together. They stand alone, therefore you can cancel off the top and the bottom. What I mean by that is we can cancel this guy with this guy because they're being multiplied, right? So we have the ability to cancel from the top and bottom, numerator and denominator, or reduce. I have more that I can cancel. I can cancel this guy and this guy. And so now I have a value or answer here of that, right? Wrong. We still need a placeholder up here. And these were technically becoming, well, 2 over 2 is the same thing as 1 over 1, right? Because it's one whole. So if you need it, you can write a placeholder of a 1 right there, because if you cancel a 2 times 2 divided by 2, 2 divided by 2 is just 1. So you could look at these as all a whole bunch of just 1s. And then we multiply straight across. 1 times 1 is 1. 1 times 1 times 2 is 2. I wanted to go through these 2 points because I think they're going to be helpful when it comes to working through all of these guys. All right, so let me start with that first one. I'm going to leave these up here just as like points of reference. 3 squared over 3 to the 5th. Now, books and teachers are going to teach this 2 different ways usually. I think it's good to see it, and then if you're getting better at it, you can just start working through it in a little bit more of an efficient manner and reduce. And what I mean by that, well, you'll see. Let's just do this. As the numbers are smaller, it's okay. You can write this out, right? We can write it out as 3 times 3 on the top, right? Because there's 2. And how many on the bottom? 3 times 3 times 3, 3 times 3. Okay. Hopefully you're already seeing that if this was like 3 to the 57th, oh my gosh, man, I'd be here forever writing all those 3s. So there's got to be a quicker way. We're going to get there. And so in order to simplify this guy, we can cancel out top to bottom, top to bottom. We know we have a placeholder because those are 1s. And so my final answer would be 1 over 3 to the third. Now, some books are going to want you to expand that out and do 3 times 3 times 3 and get 1 to the 27th. So I'll say, or 1 to the 27ths. Okay, the lesson should be on the exponents and simplifying this type of stuff. I usually accept this as an answer because it is, right? Just the fact that I changed this into this doesn't make my answer necessarily any more correct. Okay, it's still the same answer. I've just expanded this guy out. Some books like you to do that, some don't. I personally don't see a point in it unless you're going to use this as like a number for working through something else. this should be just fine because you're showing that you have an understanding of this stuff, which is the important part. As always, if you feel like you're getting it, then move on, okay? I don't want you just sitting here watching all this stuff. This is not edutainment. This is your chance to spend time practicing these problems, getting them right. X over x to the 12th and x to the 6th, okay? So now I got more x's. Am I gonna write 12 x's right here and then fast forward the video so that you don't have to watch me write 12 x's? No, I'm gonna talk about ways to get around that. Okay, we have the same base unit on the top and bottom, so we can work with these guys separately, okay? And so just like we were reducing fractions over here, we can reduce these the same way. And so how many do we have on the top? We have 12. How many on the bottom? There's 6. So we could say to ourselves, well, I'm going to take all 6 out of the bottom because I know that there's that many. And I know that there's 6 on the top because I got 12 total. So how many are left on the top? Just 6. And then how many are left on the bottom? None. So we can just put a 1 there, okay? And so again, by just looking at the exponents, we're able to reduce this down. Now there is a subtraction method and I'll talk about it in a little bit. I want to get you through the basics of this, just how to simplify when you have exponents on the top and bottom, okay? You need to have the same base unit and then you can work on it like that. Okay, let me get this guy out of the way. And right the next one, I'll do red. Let's see here, 10a to the 3rd and 5a to the 2nd. Okay, now this is all being multiplied, and the only reason you're being given these types of problems is because they're being multiplied. If they weren't, then you couldn't be doing what you're doing. Because they're being multiplied, we can separate out all this stuff. Just like I did 2 to the 3rd, I did 2 times 2 times 2. I can separate this by values as well. I can separate it as 10 times, let's see here, a times a over 5 times a, and then I can reduce that way. So let me go through it a couple different ways, and then you pick which way you think is going to be best for you. By this way, what I did was I just rewrote the numbers and then all my a's, okay? And then you treat the numbers just like you would the exponents, and you try to simplify wherever you can. But let's do the a's first. So when I say that, I mean a over a is just 1. I can cancel that a with that a, and I'm left with this. The fraction I can reduce. I can make that a 2 over 1. And when you're done or you have nothing left, multiply it all back out and come up with a final answer for your expression, right? This is not an equation because there's no equal sign. 2 times a is 2a. What's on the bottom? Just a 1. So, I mean, I could write it over 1, but I don't think it's really necessary. You could just leave it as 2a. All right. So let's move on to this next guy here. Let's see what you get. We have 3c over 15c to the 3rd. Okay. As you're getting better at these, if you want to write it out separately, you can. I think it's very visual if you see that I separate them out. So if I write it as 3 times c over 15 times c times c times c, I think it's very easy for you to look at it and say, oh, I got numbers here, I got c's here, good to go. We cancel, let me use a darker color. We cancel that to that. Oh, done with my c's, but I do have a fraction I can reduce. I can reduce that into that, okay? So 3/15 becomes 1/5, and now I'm pretty much done. This is where keeping your work nice and neat is gonna pay off. 1 times, this is just a 1, I guess, so we just have a 1, and I have a 5 on the bottom. And because I still have 2 c's left, you can just put them back together and just make it c squared. And that would be the answer for your expression. I wanted to add numbers in and exponents just so you could kind of see that it's really the same thing, and hopefully they're not going to give you fractions that don't reduce, because what's the point of that, right? The point is that you're seeing the fact that this is a simplifiable fraction. Is that even a word? I don't know. But the fact that you can simplify that fraction and then simplify all of these c's and c's or x's or b's or whatever it is. Okay, so I want to get into one last part. If you've gotten it down to this far and you're understanding simplifying these exponents and stuff, then I would stop there. I'm going to build a whole other lesson on this whole other thing I'm going to do. So if it doesn't make sense, don't worry about it, okay? Let's do x to the 5th and x to the 3rd, okay? And we're going to look at it in a different way. This divide sign here is kind of like a different type of barrier versus an equal sign. And we can move stuff from the bottom to the top and from the top to the bottom. Again, I'm kind of leading into a different lesson on using this whole like subtraction method. It can be very helpful. Some people like to look at this problem and say, well, I got 3 on the bottom and 5 on the top. So I can just cancel out all 3 on the bottom and cancel out 3 on the top, and I'm left with 2. And so my answer is just x squared, okay? But the rules of algebra allow you to move stuff around in a certain way. So let me rewrite this. We have x to the 5th and x to the 3rd, okay? And so in order to move this guy up to the top, what happens is you move it up, but instead of having it as a positive exponent, it becomes a negative exponent, okay? And just like if you were to move this guy down, it would become a x to n, x to the negative 5. If this is getting tricky, don't worry about it, okay? I'm gonna do another video, or check out my other video that's gonna be working with this kind of a thing, because it can be helpful as you move on into other types of math. And so from here, we just multiply straight across. X times x to the 5th times x to the negative 3rd. Well, the rules of math say that when you have the same base unit, you just add up the numbers on top and come up with your final solution. Just like over here, if we go backwards, 2 times 2 times 2 is the same thing as 2 to the, well, how many are there? There's 3, okay? If we have a times a times a times a times a, okay? They're all the same thing, so we can treat it as a to the 5th, right? Because it's all the same thing. Same base unit. If you want to look at it as this, technically it's just a to the 1, okay? And so if we have 1s there, maybe that makes it a little bit easier for you to work with this, because when you have the same base unit, you can add all these exponents together. And so a to the 1st times a to the 1st times a to the 1st, a to the 1st, a to the 1st is a to the 5th, okay? And so because we have the same base units, we can add these two things on top. So we end up with 5 minus 3. It's okay if it's a negative. 5 plus negative 3, if you want to look at it that way. 5 plus negative 3 is 2. If this method is getting a little bit tricky, like I said, if you're like, I don't understand what he's doing, it's okay, because there's another video I'm going to do. This is starting to kind of up the ante, okay? This is getting a little bit more technical. It's good stuff to know, but it wasn't the focus of the lesson, so I don't want to go too far astray, okay? But if you're getting it, or if you're starting to kind of see what I'm doing, then you'll just be that much better off as you move up into your math. Okay, so good job today. Check out my other videos, subscribe to my channel. Thanks for watching. I do appreciate it.